Can exponents explain fractal patterns? Have you ever looked at a snowflake or a fern and wondered why they look so similar no matter how close you zoom in? This fascinating phenomenon is tied to fractals and exponents. Let's break it down. Fractals are unique shapes that show intricate details at every scale. They repeat their patterns, whether you are looking at them from afar or up close. This self-similarity is what makes fractals so interesting. Unlike regular shapes, which change size based on whole numbers, fractals often scale using fractional or non-integer powers. This is where exponents come into play. Exponents tell us how many times to multiply a number by itself. For example, to raise to the power of 3 equals 8. In the world of fractals, we often use fractional exponents to describe their dimensions. The fractal dimension indicates how completely a fractal fills space as you zoom in. This dimension can be greater than the usual dimensions we assign to shapes, like one-dimensional for a line or two-dimensional for a square. Take the Mandelbrot set or the Sierpinski triangle as examples. When you scale these fractals up or down, the detail changes according to a power law involving fractional exponents. For instance, when you double the size of a Sierpinski triangle, its measured size changes based on a fractional exponent linked to its fractal dimension. This shows how exponents are essential for understanding fractal patterns. In real life, exponents help us describe how fractals appear in nature and technology. Many natural objects, like coastlines, clouds, or tree branches, have complex patterns that can be modeled using fractals. Scientists and mathematicians use exponents to analyze these patterns, making it easier to understand how they work. Exponents also allow us to express very large or very small numbers, which is helpful when dealing with fractals that cover vast ranges of size. Negative exponents can represent inverse scaling, which is useful for examining fractal details at tiny scales. In essence, exponents are not just basic mathematical tools. They are key to explaining and describing fractal patterns. They help us express how fractals scale and repeat their structure across different sizes, revealing the fascinating numerical relationships behind these complex shapes. Understanding this connection helps us appreciate the beauty and complexity of the world around us.